So, where does imagination even come from? That ability to replay a memory, or plan a vacation, or just get totally lost in a daydream. It feels so human, right? It's like one of the things that defines us. But what if the blueprint for that inner world, for that mind's eye, is actually way, way older than we are? Let's dive into the research and see what we can find out. To even begin to find the origin of imagination, we have to start with a pretty simple question. Is it just us? Do other animals have an inner life that's anything like ours, full of memories and plans for the future? Honestly, the very idea that animals can imagine has been a huge point of debate for a really long time. Now, we do see these incredible hints. We see great apes that plan ahead, saving a tool that they know they're going to need later. We've seen rodents and birds that show this amazing memory, remembering not just where they hid some food, but when they did it and what kind of food it was. These behaviors definitely suggest something more than just basic instinct is going on, right? And this is the wall that researchers always seem to hit. See, just watching an animal's behavior isn't always enough. Without them being able to just tell us what they're thinking, we can't be 100% sure that a really clever action is being driven by a rich internal mental movie. So, to get past this, we have to go deeper. We actually have to look at the hardware itself. Okay, so let's switch gears here. To figure out if animals can imagine, we first need to find the machinery for imagination inside our own brains. I mean, what does the neurological blueprint for a story engine even look like? So let me introduce you to our prime suspect. It's called the default mode network, or DMN for short. The best way to think of it is as the brain's own internal virtual reality simulator. It's this whole collection of brain regions that actually quiets down when you're focused on an outside task, like, say, catching a ball. But it roars to life when your mind is just left to wander, when you're daydreaming or thinking about the past or planning for tomorrow. And here, looking at the human brain, you can actually see the main hubs of this network. It includes parts of the brain you've probably heard of, like the hippocampus, which is absolutely crucial for memory, and the prefrontal cortex. Whenever you're just lost in thought, these are the areas that are buzzing with activity, all working together to weave the fabric of your inner world. And what's so cool is just how versatile this network is. It is not a one-trick pony. The DMN is fired up across a huge range of things we connect with imagination. We're talking recalling a specific memory from your childhood, picturing a future event, trying to come up with a creative idea, and even trying to step into someone else's shoes to see their point of view. It's the engine for all of it. Okay, so we found the brain's story engine in us humans. The next critical step, of course, is to figure out if this is some brand new human invention or if it's an older piece of machinery that we actually share with our evolutionary relatives. This is it. This is the key question. Because if we can find a similar network in other animals, and, this is important, if it's involved in similar kinds of tasks, well, that would be incredibly powerful evidence that they too have the ability for this kind of mental simulation. And wow, this image just says it all, doesn't it? On the left, you've got the human DMN, and on the right, that's the same network in a rat brain. Scientists call these structures homologous, which is just a fancy way of saying they share a common evolutionary ancestor. The layout it's strikingly similar. This is no coincidence. It's a shared family blueprint. And the really crucial thing to get here is that this isn't just a surface-level resemblance. The research confirms this on so many levels. We're seeing the same core brain structures, we're seeing similar patterns of how those structures are wired together, and, critically, we're seeing evidence that they're used for similar jobs. And that functional similarity is the real clincher. When scientists test rodents on tasks that need some planning or inference, like figuring out that if A is better than B and B is better than C, then A has got to be better than C, it's these DMN hubs that are essential. If you damage or turn off these areas, their performance just tanks, pretty much the same way it would in humans. The hardware is doing a very similar job. So, now that we found the shared network in different kinds of mammals, we can actually use the evolutionary record to trace it all the way back to the beginning. When did this powerful cognitive tool first show up? And this right here, this brings us to the big aha moment of this whole thing. The central argument of the research is that the fundamental blueprint for this network, the very foundation of what we call imagination, first emerged with the very first mammals, hundreds of millions of years ago. Now, this wasn't just some minor tweak. We're talking a massive upgrade to the brain. Early mammals developed a brand new brain structure called the neocortex. At the exact same time, the hippocampus, that key memory center, went through a huge reorganization. Together, these changes created a powerful new architecture for processing information, one that could support this incredible new offline mode of thinking. So, what does this all mean? Well, the fact that the actual hardware for imagination is so ancient and so widely shared, it has some pretty profound implications for how we see ourselves and the rest of the animal kingdom. This quote from the philosopher Daniel Dennett just captures the survival advantage of this perfectly. Think about it. An animal that can simulate a future path, like how to get some food without running into a predator, can test out different plans in its head first. It can let the bad ideas, the bad hypotheses, fail in the safety of its own mind, instead of out in the real world where one mistake could be fatal. So the final verdict is basically this. While human imagination, supercharged by language and culture, is absolutely extraordinary, we're definitely not alone in having an inner world. The foundational neural hardware, that story engine itself, is an ancient mammalian trait. It's a piece of cognitive machinery we share with a huge, diverse family of creatures. And that really leaves us with one last, big, thought-provoking question. If the hardware for this kind of mental simulation is so deeply rooted in our shared biology, what other cognitive and emotional experiences might we have in common with the rest of the animal kingdom? What other secrets are we only just beginning to uncover?